Hello, welcome back to another video. Today we're going to be looking at the graph of potential energy during a reaction. So the question reads, certain chemical reactions are often used to reduce swelling after an athletic injury. In a lab experiment, the following reaction was tested and the sketch graph below was obtained. So you have NH4Cl plus H2O giving you NH4 plus, Cl minus and H2O. We can see that there's a graph, potential energy graph, and course of reaction. Question 8.1, is this an exothermic or endothermic reaction? So from the shape of the graph, we are going to say that this is an endothermic reaction. Okay, so I can quickly just sketch out the shapes for you. So if the shape follows like this, then that is an endothermic reaction. If the shape is like this here, then that is an exothermic reaction. Okay. Now, next question reads, explain the answer to question 8.1. So why are we saying that this is an endothermic reaction? The reason is because the energy of the products is greater than the energy of the reactants. Okay, and let's just remind ourselves of the different sections in the graph. You have energy of reactants at the beginning, then you have energy of products at the end, then we have something called delta H. Delta H is the difference between the energy of the products and reactants. We also call this enthalpy. And we have this green line from energy of reactants all the way up to the maximum point. That's called the EA, or the activation energy. And this, in this case, it's going to be for the forward reaction. Okay? Now, let's move on. The question 8.3 reads, state the enthalpy of this reaction. So let's remind ourselves again, just one more time. Enthalpy is the value that is between the energy of products and energy of reactants. Now, you can calculate enthalpy. The formula for enthalpy is energy of products minus energy of reactants. Now, in this case, since the energy of reactants are 0, we can read it from here. The enthalpy is simply going to be 14,8. So 14,8 kilojoules per mole. Okay. Question 8.4, which number on the graph represents the enthalpy for the reverse reaction? So 8.4, so enthalpy for the reverse reaction could be number 6. It could also be number 1, since they also show it's pointing for the same thing. Now, the actual memo for this gives a different answer, and that's because I believe that there was a typo. I think the question was meant to be which number represents the activation energy for the reverse reaction. But according to this question that's given to us here, the answer should be 6 or 1. 8.5 we'll leave out the definition. 8.6, give the number on the graph that represents the activated complex. Now, the activated complex is the point right at the top here. So that's number 3. And question 8.7, explain how a catalyst would affect the activation energy. So a catalyst decreases the activation energy. Okay, that's what it does. And so it decreases the activation energy and thus increases the rate of the reaction. Okay, next question reads, 8.8, redraw the sketch on your answer sheet and use dotted line to indicate the changes after adding a catalyst. So if they add a catalyst, if this is our original graph, here, let's sketch that out like this. If that's our original graph, A catalyst will decrease the activation energy. Let's remind ourselves the activation energy is this line from reactants to the top. So it's going to decrease that amount. So maybe it will be here. So how do we sketch that? We'll sketch it like this. So that's all it does. It just decreases that value from there to there. That's what it does. Okay. And that's it for this question. If you found it useful, please leave a like, share, subscribe. If there's something specific you'd like me to do, let me know in the comment section below, and I'll see you in the next one. Bye-bye.